Today we are overwhelmed with data. We have social apps that are connecting people as never before and generating vast quantities of data. We have mobile devices deeply embedding applications into our daily lives and being there to capture our activity as it's happening in real time. We've got the Internet of Things that are allowing us to capture human context by turning every device we touch into a data generator. And we've cloud, providing a software delivery platform that makes it increasingly easy to collect and store all this data. And finally, we have analytics systems, allowing us to analyze this data to unprecedented levels of granularity and depth of insight. This perfect storm is putting huge pressure on us as analytics professionals to have all the answers, to be able to generate insight that will transform how our businesses make decisions. This means understanding the applications that are generating the data, the context around which the data is being generated, where these applications sit in the business, and how they contribute to business outcome. We are expected to know more than is possibly knowable by a single person, which is made worse by the growth of data lakes, where data generated by one line of business is being shared by another to generate insight for a third. This spaghetti of data and insight cannot be navigated without the combined effort of a network of collaborators. And to make things even harder, as analytics becomes increasingly embedded into the business decision-making process, so will the demands on us to prove quantifiably the quality of our data, analysis, methodology, and conclusions. Some of these demands may be driven by regulatory requirements, but others will be driven by the need to build trust with the consumers of our insight. If someone is going to make a critical business decision based on our analysis, they need to be very confident it's the right conclusion. All this means that there is a significant pressure on us as analytics professionals to build trust and confidence between those of us generating insight and those consuming it. This means capturing provenance. We need to be laying down digital breadcrumbs at all steps of our analysis process, and this includes capturing all variation of contribution from across participants in the analysis project. These growing demands cannot be solved by technology alone, but must explore ways that we can maximize our human capital through allowing greater engagement and knowledge transfer during the analysis process. For us to be successful in this new analytics environment, we need collaborative analytics. When we think about collaborative analytics, it's important to consider it from two perspectives. Firstly, it's about collaboration, where we need tools that facilitate broad engagement in the analytics process. But secondly, it's about analytics, where we need to apply sophisticated analysis on the collaboration data in order to move from just collaboration to cognitive collaboration, where our collaboration activity helps us capture institutional knowledge, or what some folks refer to as tribal knowledge, and allows us to use that to make us smarter, whether that is through improved search and discovery, automatic tracking of provenance, organizational analysis and insight, data assessment, crowdsourcing, expertise location, etc. This combination of collaboration and analytics fundamentally changes how we do analysis projects. So how do we turn collaborative analytics into a reality? Well, firstly, we provide a collaborative environment that not only supports broad engagement during the analytics project, but which also captures and translates all this activity into a contextual knowledge graph on which we can apply sophisticated analysis to support us in our explorations and make us smarter and more agile. In a few minutes, we're going to give you a quick demonstration on how the collaboration experience looks. But secondly, we also provide collaboration as lightweight embeddable services that can be integrated into any application. So for example, within our own internal IBM data lake, we have added collaboration services into our IBM governance catalog in order to help us crowdsource the semantics of data and to allow anyone interacting with data to share their experiences, perspectives, and knowledge with the broader analytics community. Now, this is seamlessly facilitated through the underlying knowledge graph into which all this activity is fed. Now, I won't be demoing the social features in the governance catalog, so I just wanted to give you a quick screenshot so you can see the types of services that are provided to our data communities. So here you can see that by adding collaboration to our governance catalog, we can now allow our data folks to flexibly tag assets, add comments, track consumption, rate assets, follow assets or groups of assets. So this not only supports crowdsourcing, but it also captures all this valuable interaction into the knowledge graph so that it can then be used to help the data scientists who are looking for data, and I'll show you that later. But also similarly, the data science activity in the knowledge graph could then provide insights back to the creators of the data. So give them feedback, for example, on how some of these data artifacts are being consumed across different analytics projects. And finally, the knowledge graph then gives us a much smarter search and discovery experience as an example, and I will show you this during the demo. So now let's get started with the demo. The data science process generally starts with a question, and in this case we have Kelvin. Kelvin would like to be able to predict which of his buildings have insufficient energy usage patterns. He will create a project. In this case he adds Marie to the project, and he then enters his question. He already has found a particular data set that's inadequate, but it's just the starting point. So he attaches that data set to his question. He posts it into the project so that Marie can then respond and get things kicked off. Here you can see that Marie reads Kelvin's request, sees what he wants. She obviously believes Adam is the right person to work on the project, so she adds him to the project, and then she asks him to actually work on this. So you can see that she mentions him, and that means then he will get notified that he's been mentioned in a message. So like your standard social system. So now he's notified and he can get started on the project. Adam now starts by looking for some potential data sources. Thanks to our knowledge graph, our expanded search is able to find projects, people, data, and other types of artifacts. If Adam clicks on the project, this will bring him back to the project activity stream where all the data, conversations, conclusions, etc. are stored. So that means that the searcher can now leverage data or insight from, in this case, the Boston project, just as Adam did. In this way, he is able to find Stephanie and her project, which has a data set that could help him. She is also able to give him some recommendations on algorithms he might want to use. And the key thing here is that through this activity stream, Adam is able to capture all these interactions for everyone else on the project to see. And in the underlying knowledge graph, it also makes the connection between Stephanie's project and Adam's project. This is good for the individual, since it allows Stephanie to get credit for supporting Adam on this project, but it also shows the similarity between the two projects and the respective data sources, which essentially crowdsources additional data about the artifacts, including generating good consumption data. Adam can now work on the combined data set. After some experimentation, he decides to use Watson Analytics to visualize his results. He first loads the data back into his project activity stream so that it's there for everybody to see, and then deploys the data to Watson Analytics. He goes into Watson and loads it in, and Watson then suggests a visualization for him. He's happy with the results and decides to push this back into the activity stream, adding a comment so that everybody knows what he did. Kelvin is happy with the analysis and the project is now complete. However, this project and all its activity has been built into the knowledge graph, ensuring that it is easily findable by other projects, that the provenance has been captured so that consumers of the insight can now see how the result was generated at any point in time. And it also contributes to the institutional or tribal knowledge. And just before we finish up, there's one final thing I wanted to show you, and this is the contextual search from within Watson Analytics. We showed you that within the activity stream, Adam was able to search for data sets, and he was able to get back not just data sets, but also notebooks, other projects, people, and so on and so forth. But this search is a microservice that can be integrated into any application. So it can be integrated into Watson Analytics to give Watson Analytics the same type of contextual search that we get within the activity stream, and this is just showing you. So you can see here when you enter the search, instead of just getting data sets, you're getting data sets and projects and people. You can click on those. They will bring you right back to the activity stream where you can see again all the provenance around the project, and this way it allows the activity stream and the collaboration to really be pervasive across any of the analytics applications that you might be using. Well, with that said, I'm going to finish the demo. I hope you found it useful. If you're interested in finding out more, please do reach out to me. My contact details are on the screen. You can find me on Twitter at Marie_Wallace. I have my blog, allthingsanalytics.com, or you can just find me on LinkedIn. So I hope to talk to you soon. Bye.